Hi guys, in today's video I want to show you how you can navigate through different function calls recorded in a TTD trace. And for that purpose I will use some of the functions that I published in the LLD ext extension available on GitHub. It's open source, and in the repository you can find multiple functions or WinDbg extensions for various purposes, including the work with TTD traces, and that's the section that you can find here in the README file. And some of those functions we will use today. I just want to present you how you can start using them, and maybe you'll find them useful for your diagnosing scenarios. So let's start from recording a TTD trace. We will record the execution of the dir command in cmd.exe. So let me go to maybe a folder with a bigger number of files. That could be C symbols, and then I will execute the dir command whilst I attach the debugger and start recording of the TTD trace. So I'm going to use WinDbg, but of course you can also use the ttd.exe, so the command line client for time travel debugging. The nice thing about the TTD client is that you can stop recording without terminating the process. With WinDbg we will need to exit the process to stop recording, but for our demo it is just enough. So let me start the recording. Let's save the recording in the temp file, and I will run the dir command. And as you can see, there are multiple files here, and then I will exit the process that will terminate the trace collection, and the trace got indexed, and we are ready to start analyzing the file. I already added the scripts folder from this repository, so I cloned the repository and then I added the scripts folder to my path. So when I type script load and then lldx.ext.js, WinDbg will find it in the path environment variable. So that's the folder where I cloned my scripts, and I'm ready to go. So we can start using the commands from this extension. And the first command I want to show you is something called call stats, and as its name suggests, it shows us the statistics of calls of functions that we it shows us the statistics of calls of functions in a TTD trace, and it does not accept the function name immediately. We need to pass a collection of calls, and for that we could either use, normally I would use the car session, then .ttd calls, but I also added an alias for that, so I just simply type calls, and then we can use just the regular name, or we can also use wildcards. So in this example, I know that CMD is probably using one of the find commands, so let's try to add a wildcard and then search for all the statistics of calls to those functions that are matching a given pattern. And I will close the parentheses, and then I will display the results in a grid. So let's run that. I already have symbols, and we can see that cmd.exe, the dir command, is actually using that I would say the standard way of enumerating files in a folder. So it starts with the find first file exw, and then it calls find next file w until it returns a null result, and then it closes it. So we can see that we executed dir once, and we can easily see that the number here will probably match the number of files and folders in the C symbols path. So let's now focus on those calls, and we will first start by looking, or maybe showing the parameters to the find first file ext exw. So let me show you the function definition. We can see that it accepts the file name, so that would be the place where the search starts. So let's see what CMD is actually sending as an argument to this function. And we'll again use one of functions from the LLD-ext extension. And but this time, if you look at the parameters here, we know that the file name here is a pointer to a string. So when the calls object actually it will be easier if I show it. So let me show it. Kernel base find first file xw, and if we make it a recursive display, we can see that the call to this function has property parameters, and this is a collection of addresses or values depending on what type of function we are dealing with. And if we do not have private symbols, so if we do not know the exact name of parameters and types of parameters, we'll simply see a list of hex values or numbers, as you can see here, and it only shows the first 4 of them. But in our case, that's actually enough because we are interested in the first parameter. The problem is that if we try to dereference this address, let's say at the beginning of the trace, it might not necessarily be the right string, because it could be either something else might be written there, or well, it might contain invalid data, so it could be even not allocated yet. So how we can deal with that? There are 2 approaches actually. One is that we can use the memory object, the memory API from the WinDbg API, which allows us to read from a given address at a given point in time, or we can jump to this time in a trace. So if I go use this address and then simply type TTD and then actually it's TT, and then type the time position, we'll jump to this place, and at this point this address will be valid. So if I try to dereference it, I know it's Unicode, then we can see that its value is C symbols and then wildcard. So that's what dir command is. This is the way how a dir command calls it. So what if we want to analyze more functions like that? In our case, we have only one function, but we could have multiple of them, and we will actually look at the results of the other functions. So we'll see that in play. But let's do this experiment first on this function. So what if we would like to present the parameters from all the calls to those find first file exw function? We can again use the dx calls. But before we do that, I will actually use another function which also comes from the LLD-ext extension, which is seek and get. And this function will actually work with not only calls, but we can also use it for events, like for example exceptions. And what this function does is that it takes the collection of objects that we want to use. So in our case, it will be calls to kernel base. Then let me copy that. Kernel base find first file exw. Okay. Then we need to define a function that will pick the time at which we should use to execute the time travel. So what we are going to do here, I mean the seek and get function, what it will do, it will take the calls which are defined here, and for each call it will perform this jump that we just did here. So it will jump to the place where this call start. It could be of course also time end, and then it will execute the function that we defined here, so the last parameter. And here we will extract the file name. So we are going to create new anonymous object with a file name, and then that would be a Unicode. So we'll just cast the parameters dot 0. That was the first parameter, and we can of course add those other parameters which come to this function, like this info level ID, if we want to do that. But for our purpose, I will just print the file name, and that's it. So let's just run it. Let's print it in a grid. As you can see, the jump happened here. So the second get function jumped to this place in a TTD trace, and then it executed the command. So it dereferenced the parameters. So that's the first example of usage. The other one is a bit more complicated, because in this one we are going to look actually at the result of a function call. And as an example for this function, we are going to look at this find next file w, so the other function that dir command is using. So to this function, we can see that it returns the result in a special structure, which is a Win32 find data. And we are actually interested in the Unicode version, and one of those fields in this structure is the file name. So this is the file name. We can see that it could be at the maximum max path length, and this is what we are going to print. And so as you can imagine, this part will be a bit more complicated, but not that hard. The first thing that we might be problematic is that we might be missing symbols for the Win32 find data W, and we can check actually that those symbols are not present in the kernel base DLL. So let me just do that, and we can see that they were not found. They were not found. But interestingly, that's what I often do. I search in the Combase DLL, which it's one of the DLLs for which Microsoft publish private symbols, and often you can find those structures, structure definitions in the Combase DLL. And here you can see that the Combase actually contains this structure, the symbols for this structure. So we have a full definition of it, and that will make our life much easier, as you will see in just a moment. And just to prove that it's the same structure as we are using the Unicode, the one with a W suffix will have exactly same symbol. Okay, so let's go back to our trace, and we'll again use the seek and get function like before, but this time we are actually interested in the moment when the call ends. So as before, we are going to use the seek and get function, but this time we will look for the find next file, find next file W, and not time start but time end. And we won't have the file name in the first parameter like before, so instead we are going to first cast the second parameter to the function to this Win32 find data W structure. We can see that the second parameter, so let's extract it. So C parameters 1, and once it's casted, we are going to I just need to make sure that the parentheses are correct. So we are going to extract the C file name field. Let me check if it's the right field. C file name should be fine, and this is what we will cast to the white car. And okay, let's execute that. and this time, as you can see, there are much more time travel jumps. We can see that the secant get function was jumping through the TTD trace, but we can also see that it showed us the returned values. So that's what the dir command was putting in the output, and that's what we saw in the console. And that's the way how we can extract this information. Another little function that I wanted to tell you about, or actually a way how you can even narrow down this trace. So let's assume that we called the dir command multiple times, and we know that and we are interested only in one of those calls. So what we could do is that we could let me maybe print the call stats again. So call stats, and so we can take the time of the first call. Actually, that would be better. We can take the time, the time start of the first calls from this this value. Let me open Notepad so we can save it. And we can take another time. Let's say this one. That's the narrow down the function, the period of time on which we want to focus. So this is how we can do that with the, I will modify the secant get command that I already have here, and I will add a filter here. After we take the find next file w call, we can actually add a where condition here, and the where condition, again, we need to take the call, and then we will narrow down the calls by their, let's say, time start. So we want the time start to be bigger, or actually bigger than, and here's the problem, because the time start is of a special time, like of a special type, time position, and we need to convert these values of this string that represents the time position to the time position object. And I also created a little function for that. So that's time pause, and it accepts this string. Oh, actually not this one, but I want to have the first one. It accepts this string, and it creates the time position object. And we are going to also make the time start smaller or equal than, and again the time pause function, and here we will put this other string that we saved before. And if I run this function again, I should have the small number. Of course, we can see that actually we only have 20 of them, and those are all the functions, function results actually, that were executed in this period of time. So that's it for today. I hope you will find this extension useful, and I wish you happy debugging. Thanks.